Okay, I'm going to go ahead and get started then. Good morning and good afternoon. My name is Lisa O'Brien, and I'll be your host today. Welcome back for our third episode of our second season of our Get a Grip webinar series. We're going to continue with the same style we tried last month and keep the conversation going with two new speakers. Before I introduce our speakers, I want to introduce today's topic, which is From Old Floor to New Flow, Brownfield Automation Done Right. Today, we plan to focus our discussion around learning proven playbooks, seeing real-world examples, and discovering integration best practices. A couple notes before we get started. If you have a question, please put it in the chat and we'll address it at the end. And also, as always, today's presentation will be recorded. We'll send a follow-up email to everybody with the link to the recording. Moving ahead, please join me in welcoming our guest, Christina Gomez-Terry, VP of Operations at Plus One Robotics, and also Ethan Landefeld, Senior Product Manager at Plus One. I'm going to give our guests a moment to introduce themselves, starting with Christina. Christina, please tell us a little bit about your background and what you do at Plus One.
Sure thing, yep. So I was born and raised in San Antonio, Texas, which means I'm a native Texan and a native San Antonian, and very proud to be able to find exciting work in robotics and logistics here in my hometown at Plus One Robotics. My background is in mechanical engineering. I graduated with my bachelor's from MIT. Then from Boston, I came back home because it was too cold. I started work in a career a little bit more chemistry related, then pivoted back to get my master's in mechanical engineering from the local university here, UTSA. At that point, I was able to get into robotics and automation, and then I was able to start at Plus One about 7 years ago, just as like a field deployed engineer, programming robots and helping install and configure our vision software. As the company grew, I had the opportunity to grow and be a manager, and then eventually work my way up to director of operations. And I've been lucky enough to follow that career trajectory all the way up to the vice president of operations. I hired our first European employee in those capacities. And as I mentioned, when the company was growing, I was growing, and I've basically overseen all of our field deployments, both in the US and in Europe.
Awesome. Thanks, Christina. Let me move the spotlight over to Ethan. Ethan, would you please share with our audience who you are and what you do at Plus One?
Sure thing. So I'm Ethan Landefeld. Much like Christina, I also started my career with a bachelor's in mechanical engineering, but I went into the oil and gas industry as a design engineer for several years. Then went to study business for my master's and pivoted into product management. So I've done that now in a couple of different industries, the latest of which being logistics robots here at Plus One. I've been here for the last 4 years, and my role as senior product manager is to basically define and manage our product roadmap and make sure that the output of our brilliant engineers is actually solving the right customer problems.
Yes. And I feel like both of them also do a lot more than they're sharing here in these brief introductions. Christina and Ethan are both veterans at Plus One, and people look at them as, you know, they're a part of our leadership team. Before we get into our Q&A, I want to show a couple of videos to give some context to some of the discussions we'll be having. This is one on our newest product, DPAL 1. It is a portable and flexible automated palletizing and depalletizing solution. If you're with us last month, then you would have seen this video too, so bear with us here. I'm saving you guys from the jazzy music that's happening in the background, by the way. But these are also on our YouTube channel if you want to check that out. And then the next video is going to be on Induct 1. And this is our dual arm induction system for high-speed induction. While it's not a plug-and-play solution, it's about as close as you can get in the market right now. Ethan, I chose the video that didn't have any text over it. So if there's anything you want to add, please feel free to speak up.
I think you did a great job giving an overview.
Okay.
Yeah.
Okay. All right. So let's get into our discussion. I'm going to stop sharing this screen. Okay. Hang on a second here, guys. So, Ethan, let's start with you and your insight or experience around brownfields in general. What are the biggest misconceptions you encounter when teams approach brownfield automation projects?
That's a great question. I think one of the biggest things that people often underestimate is actually the integration side of things when bringing automation to a new facility or to a brownfield, I should say. So we've actually had some customers that have overlooked this early on in the planning phase and then really paid for it later because they realized later on, oh, this is actually the bottleneck, and now my schedule is getting delayed. So at Plus One, in product, we strive to always make things as plug and play as possible, to require less of an integration burden, but most automation does not exist in a silo. And so you're always going to have some kind of integration, upstream, downstream communications, running utilities to the machinery, and then also, some minor site modifications at a minimum with regards to in-feed routing and out-feed routing. And again, back to the product side of things, with the Induct One cell that you just showed in the video, this is something that we kept in mind from the very beginning. We did, it will work in greenfields, but we designed it specifically to fit into a large majority of brownfield applications. And so we went out to a lot of different facilities, and we had our concept of how this cell should look, and we took a lot of measurements, looked at a lot of CAD, come up with something that was going to be replicable across different brownfields without the need for any kind of major changes on site. So we made the cell as lightweight as possible and as compact as possible so that there's no actual need to add additional significant structures underneath mezzanines, for example, when adding the robots on top.
Christina, did you want to add to this?
Yeah, as far as misconceptions, I think one of the things we run into as well is the expectations around the testing and what is acceptable for the FAT or the SAT, which is the acceptance testing, and that translating directly into success in the field. So just for example, if you run a factory acceptance test in your facility with ideal packages, you can hit certain rates with certain criteria. But then when you ship to sites, it may not run that way. Going back to what Ethan said about the surrounding factors. So your in-feed may not be feeding consistently, or it may be lumpy, or it may be too much and it's overflowing. And there's ways that the package flow goes through the facility that will affect kind of the throughput of your system. So you're kind of going into a process flow that already exists when you're doing brownfield and it's a retrofit. And so there's a lot of upstream and downstream equipment, processes, communications, integration to keep in mind when you're trying to fit something into an existing flow. One of the other misconceptions is just that you have a facility and you think you know what's going on in there because you have things coming in and things coming out and a process happening in the middle, and it looks like everything's running how it should, but there's a lot of little things that are happening in that middle that are not necessarily being reported or caught, or maybe just don't have a full understanding of your package set. So One of my other points is just the product flow and composition is maybe not known upfront. So, percentage of poly bags versus boxes, or how much debris you get flowing through. A lot of people don't know the flow of their parcels in very in depth and in detail to where they could tell you, this is what you're going to see, this is the mix, this is how you will determine what those KPIs will be, both for the FAT and the SAT. It's very dependent on the shift and the season and a whole bunch of other factors. So I'd say the knowing what your product set is probably a misconception, that people think they know what they're running, but they probably don't have 100% idea.
Right. And it's my understanding that the majority of clients don't seem to know. When we go in and ask some of these questions up front, they need to go and do their own investigating, because they haven't always, maybe it's not something that they've had to consider before. Christina, I'm going to stick with you on
Sorry,
this.
Lisa, can I jump in on that one? Christina,
Yeah.
I really like that point about some of these things that people are doing inside the facility that are not well known. And we see this a lot, actually, like when you do a jobs to be done analysis of induction, for example. At a very high level, it might be, okay, I'm going to singulate a parcel from a bulk. That's what people look at a crinkled up poly bag and they'll flatten it out, or they'll flip it over, or do all these kinds of little things that are not technically in the job description. But humans just kind of intuitively know how to do them. So when you're automating, you have to keep a really keen eye on these things, to be explicit about what are the requirements, what are humans just intuitively doing, even if they're not told to do.
Yeah, great point. Okay, Christina, I'm going to move to you for this next question. It has to do with realistically installing, what did I have here? What it's like to realistically install state-of-the-art technology like robotics alongside plant managers, plant engineers, and hourly folks, basically a diverse swath of people and stakeholders. What's one thing facility operators tend to underestimate when integrating robotics into legacy layouts?
Yeah, and I think I'm going to pivot from or add on to what Ethan was saying. I think the humans in the process do a lot more than what they're doing, and they're really good at covering up really small problems. So if they have a small problem, they'll just figure out how to solve it and move on. One of the examples is, the downstream motor keeps faulting, but it's every other hour. So you just hit reset a couple of times and you keep going. It's probably failing, and it probably needs to, you probably need to call maintenance to get that fixed. But in the meantime, you just keep hitting reset. And depending on the operator, they will or will not report that that's what they're doing, because otherwise they're functioning, they're getting through their workday, they're able to output, everything's fine. So I think humans will do a lot of resetting or recovering that isn't reported and isn't captured anywhere. And then when you put a robot and automation where that human was, there's no automatic quick reset. You fault out because the belts aren't running, so you can't run. So then the cell sits there idle for a while, and everyone's like, well, what's going on? And why is it stopping so much? And it turns out, it's an external issue, but it was just being kind of masked in the short term. And eventually, I'm sure it would have just failed, and then maintenance would have been called. But in the interim, it was just being covered up. Similarly, to Ethan's point about polybags, like how humans handle packages can be very nuanced. So if it's a big poly, maybe you fold it in half, maybe you flatten it, whatever. We actually handle things, very differently than automation would. And similarly, there was a case where the downstream system wasn't sensitive to a flat piece of mail, so an envelope. So if you sent an envelope through, it would reject it back. So the automated sensors just weren't set correctly for flats. And the humans then were like, oh, if I just fold the corner and then send it through, everything's fine. So then everybody in that facility figured, oh, you just fold the corner and send it through and everything's fine. And then you put in a robot to do this, and the robot does not fold the corner, obviously, and just tries to send it through like a normal parcel. And so we were getting higher than normal levels of, amnesty or rejects because our process wasn't specifically mimicking what the humans were doing. Though that's not the intention, of course, of the downstream systems and anything else. No one was intending to have people fold these corners. So it just exposes kind of some of these things that people do to function and execute at their job that is not consistent across the lanes, across the sites, across anything. So then when you're trying to roll out automation, all of these little things start popping up. So that's, I would say, where you underestimate that you can just pop something in where there was a human operator before, because there's little nuances to how they were doing that operation, to Ethan's point on the job to be done.
Yeah, a lot of unknowns. Ethan, I'm going to come back to you. How do modular turnkey systems like those you've worked with change the game for brownfield sites?
Yeah, so I think when we talk about turnkey solutions, it's important to make some distinctions here. So there's kind of a spectrum in terms of who has scope in what is then delivered as a turnkey solution. So, and what I mean by that is the scope between what we as Plus One Robotics, as machine designers and manufacturers would provide versus what is the integrator providing. So on one end of the spectrum, kind of on the more plug and play end, is the DPAL 1 system that you showed the first video of. So that actually comes in a couple of different configurations, but the configuration you showed is with a cobot. And so this is, again, really as plug and play as it gets. You deliver it to the facility, roll it into place between a pallet location and an outbound conveyor, plug in 120 volts of power, and you're depaling in virtually no time. So that's one end of the spectrum. Then moving a little bit further down would be something like Induct 1 or the DPAL 1 with an industrial robot. And while the first DPAL 1 with cobot is a great solution for customers that are either just starting off with their automation journey in that process and are trying to prove out that, hey, this actually makes sense for us. Stuff like Induct 1 and DPAL 1 with industrial robots, this is where we get into much higher parcel variability, much higher throughput requirements. And so to actually accomplish those goals, we end up using much faster robots that require more safety guarding around them. Just quickly back to the DPAL 1 with cobot, that's also a great solution. Maybe there's a customer that's their end state of automation. Maybe they have a low SKU count, lower throughput requirements, or lower utilization. But to really get into some of these high performing facilities, you're going to have to get faster, beefier robots that have some of this safety guarding. So that's a case where then you would have an integrator coming in and designing site-specific kind of peripheral things around the system, just to really provide that turnkey solution. And then on the far end of the spectrum would be something like totally custom, where maybe Plus One Robotics is just providing the vision system, and you have an integrator designing a full robot cell and in-feed, out-feed, safety fencing, and everything. So yeah, that's what I would say to that.
Awesome, thank you. Let's see, I've got another video I want to queue up for you here for our next question. Let's start that. And I'll go ahead and ask our next question then. For Christina, what role does flexibility, whether in hardware or vision systems, play in making retrofits work in unpredictable environments?
And I wanted this video for reference just because it highlights a couple of points of flexibility that we tried to incorporate kind of throughout the years as we were developing these systems. So you can see here that that's a 4 robot system that we installed for a facility that processed quite a lot of mail. But from the hardware perspective, if you can be flexible, that really helps your potential for scalability. So we also installed a similar system with 2, 3, and 4 robots for this customer. So depending on their facility and the facility's output and requirements, then it makes sense or doesn't make sense to do some number of robots and get that return on investment quickly. So the way we approach that was, start from the end of the line and work your way in and figure out what the throughput is and what the line's throughput is and how many robots actually make sense for each facility. So I think that was one thing we did well there as far as being flexible and how many robots can be installed based on the facility requirements. Another point of flexibility as far as addressing unpredictability is, from the +1 perspective, we always like to highlight that, we're a company that focuses on the vision. That's kind of where our roots are. So we've been using AI for a long time, but we also, from the beginning, understood that AI would have some limits. And so we incorporated crew chiefs and human in the loop for these scenarios of unpredictability. A package looks like a package until it doesn't. And in the parcel world, people can ship, any number of things in any number of containers. So one of the ways that we address the unpredictability of, the packages themselves is to incorporate humans for the exception handling. And that was my last point there as well, is that whatever process you design when you're doing a brownfield application, there's almost always something coming in that you need to handle in a way that doesn't go out. So, the system is designed for, package in, package out in some way. So if it's either not a package because it's a broken package, or it's the contents of a package, or it's a piece of cardboard that got dumped out of the Gaylord, or it's an empty forever bag that got thrown in with the mix, there's a lot of not packages that get routed with the actual packages. So in those cases where something comes through your lane that should not be processed and should not go downstream, you need to design for that exception and for that exception handling. And so I think the flexibility that you have in that helps with that unpredictability. So if you consider that you will have to do something with these exceptions and design for that, then it is a better fit for the brownfield so that you can properly do that. And we do that both automatically and through Yonder, the crew chief, as far as the options of that looks like a package, let's go ahead and pick and place it and send it down, or that looks like it's not a package and it's a piece of trash and needs to just get accepted out. So for the Induct 1 example, we have 2 exception path flows, one on the pick side where if there's oversized, overweight debris, there's like I said, cardboard. If it's identified as a thing that shouldn't be inducted, then, and we also can't pick it up to do a pick and place or a pick and reject, then it can flow off the front end and just get rejected down a chute. And if it is something we can pick and place, so it's not overweight but maybe oversized, then we kind of identify that on the place side, say, oh, that's too big for the sorter, let's reject it so we don't cause any downstream issues. And so that has a different reject path. But I think being able to handle those exceptions however they come in is critical to the automation piece being successful in the existing workflow. So for a brownfield.
Yeah, 100%. Christina, I really like your point about the remote intervention, the Yonder software that we offer, and how that makes us more flexible to kind of deal with the unexpected. And I would say that's something that makes us quite unique in the market. So just to be fully transparent, it's almost like a philosophical debate on whether or not human in the loop has its merits. But we take a very pragmatic approach at +1. Like, we're not covering our eyes and pretending that these things don't exist. We know that they do, and it's better to have something to deal with things and resolve issues in a matter of seconds instead of a matter of minutes. So I think we may have some people on the call that may not be familiar with the Yonder software, but essentially, our robot induction and depalletizing systems run autonomously a very large majority of the time. But when the vision system is not above a certain confidence threshold in its next move, it has the ability to send a request through the cloud to our Yonder software. We then have humans, who we call crew chiefs, at the ready to respond to these requests. So they'll get a bird's eye image of the cell, and they are typically able to resolve these issues in between 3 to 5 seconds, send a response back to the robot, then the robot kicks back into autonomous mode and keeps being productive. Now, if you had a system like that that was not connected to Yonder, it's likely going to fault out. The stack light's going to go off, and then you're waiting for somebody to see from across the facility, oh, hey, there's a problem. I'm going to walk all the way over there, reset the cell, while a +1 system has been running autonomously that entire time.
Yes, thanks, Ethan. And for those who maybe have not caught some of our past episodes, Alex did at least one episode last year on Yonder too. So if you're interested in that, you can go and check out our playlist on our YouTube channel. I've got one more question today before we move on to the audience questions. If you had to give one golden rule for Brownfield automation success, what would it be? Who wants to answer this?
I'll go first on that one. I think it's a two-sided coin, but there are a lot of stakeholders when you're deploying any sort of automation into a brownfield, and some of it's local ops, local maintenance, but likely the incentive and the push for doing automation comes from the corporate level. So you have so many layers of people who are interested in the success and or failure of your project. And they all have different goals. They might be similar, but they're also different. So it's important to understand who all those stakeholders are and what they're looking for kind of from a performance standpoint. So you can, back to the SAT concept, you can pass your acceptance tests and the machine still doesn't run if the local operators, are having trouble resetting it or don't understand when it's faulted. So there's a lot of points for me, I think, because I'm a glass half empty person. There's a lot of people who can stop your project. So you want to make sure that you understand what those pain points are, because it can go off the rails early on, or it can go off the rails later in the project. And you really just want it to stay on the rails and then to scale. So you have to just understand, like, what are the numbers that everyone's looking at, or what are the factors that you can point to say, like, oh, what are the benefits that will showcase, like, why this is useful. And so back to, like, the process flow and Yonder, how many times do you send a piece of cardboard down that shouldn't? And you think it's 0 times or maybe 5 times, but it turns out it's happening 100 times a day. So not only is it affecting your automated system, but all the humans too. So if you can reduce that number up front in your, Gaylord dumping system, then the rest of it runs more efficiently. So I think for automation, one of the things is to point out how the observations from this not only make that lane run better, but all the other lanes around it run better. So everything should get more efficient because you're fixing all the little things that you didn't know existed, or you didn't know the magnitude at which they existed. So I think the golden rule is just to understand all the stakeholders and their pain points and how you can best describe the benefit to each layer of stakeholder that you have.
Okay. I like that. All
right.
right.
I guess I have to go now. Hard to follow that, Christina. So if I had to give a golden rule for automating brownfields, it would be to aim for an easy win on install number 1. And that ties into Christina's point about stakeholders. Like, don't pick your most challenging location or cell to do the first one. You want the first one to have as little friction as possible to get that buy-in and start building momentum. But with that, aim for an easy want to, after hitting your KPIs on the pilot, immediately be able to start executing on the rollout plan and not lose any of that momentum that you earned with the pilot. While you're evaluating those, the full rollout, like look at the entire network, because if your plan is eventually to automate 80% of the induction lanes in your network, and then you go through and you look at a specific technology, and actually it's only going to fit in 40% of those lanes, well, you might rethink doing the pilot. So just have like a full picture, really plan it out, and know where those gates are to switch immediately from pilot to rollout phase.
Great points, guys. Thank you. I want to open it up to our audience. Are there any questions from the audience today? Let's see. Okay, I see Pardeep typing. What are the costs for each robot? So I think that's dependent on which robot it is and on a lot of different factors. How many you're buying and which robot, and have you bought from them before? Are you buying more things from this particular vendor? Christina and Ethan, what other factors am I overlooking right now?
Yeah, I would say it's to your point, it's heavily dependent, right? I mean, even based on the material to be handled, you could have all clear bags of apparel versus a robot that's picking up 50-pound cases, and that is necessarily going to change the cost of the system. So, but as far as exact details, I would defer to our sales team, at least for +1 products.
Yeah. It's going to be, I mean, there's several parties involved when you do a project like this, right? Like, obviously, you're going to have the integrator too. And how do they structure everything? And is this a RAS model, or is this going to be CapEx? Or again, it's just not a straightforward answer, I suppose. Okay.
Yeah, and I would say the robot is a very large factor in the cost of an automated robotic cell, but it's still probably not 50% of the total cost. So it's maybe 20 or 30% of the cost. So the cell itself, all the hardware, all the controls, all the safety devices, the infrastructure, the in-feed chutes and other things will add up pretty quickly as well. So the robot is a major factor in the cost, but it's not the whole thing for sure.
Great. I think I see one more question coming. Ethan, did you mention that you can connect a DPAL 1 cobot cell to an existing belt conveyor?
That's right. So, I mean, placing it next to an existing outbound conveyor. At least I don't know if you want to go back to that that video. We can look at that real quick.
Sure.
Yeah.
Is next to or in front, and I think it's either way, right?
Yeah, so if you pause on that kind of side view of the full cell, point something out.
Right
Yeah,
there.
so you see like that accordion kind of gravity conveyor there. That's just from our shop here, but the cell actually contains that other conveyor section. So you could essentially butt that up against an existing conveyor.
Let's see. Lars, if you would like to, let's see, speak up. Let me see if I can unmute you if you prefer.
Yeah, I can try.
Okay.
Yeah, so yeah, the reason why I'm asking, we had previous conversations with you guys, but then with customized cells, and then we had to give up some unloading docks, or at least one, to be able to have like a depalletization robot arm. And I was curious with the cobot cell if we can like put it next to it and when we need it, and then move it away, for example, when we start unloading a trailer by hand, for example.
I see. Yeah, I think that should be possible. I know it is quite mobile, but I would say let's follow up offline. We can get a little bit more detailed into this. It's a relatively new product offering for us, but allowing a lot more flexibility into our decal offering.
Yeah, it's also new for us, and with the physical labor, because I'm from the Netherlands, we have a big topic with the labor inspection, so we have to look into, but not waste any doors that we need for unloading. So yeah, please, if
Yeah.
you can follow up after or another time, that would be great.
Yeah, I know it's generally designed to kind of have those arms at the bottom fold in and then be able to do a hand truck or a pallet jack to move it around. I don't know more specifics, but
okay. Great.
Okay.
Thanks for that.
Awesome. Thank you. All right. And John Crimmins, he is typing the question.
like he might know more specifics.
While it will ultimately depend on your setup, the Depot Cobot cell can be set up next to an existing conveyor. Okay, awesome. Thanks, John. All right, if there are more questions, please feel free to reach out to me. I can connect you with our speakers or with the right person, the best person to answer your questions. So let's see, where am I here? Guys, this has been really insightful, and I want to thank you both for your time and the overview. I'm sure the audience appreciated your insights today as well. As a reminder, everyone will receive a copy of the webinar recording via email. And a couple extra announcements today. If you plan on attending the Parcel Forum or Pack Expo, you should hit us up. So we'll have a team at both. We will have a booth at the Pack Expo in Las Vegas. We'll be in the Schmaltz booth. We'll have Deepal 1 there, actually. And let's see, this is a good email to reach us at as well. And also, let's advance here. So for next month, if you like today's webinar, please sign up for next month's webinar. We're going to be discussing unpacking Deepal, pros, cons, and candid talk with Jose Hotema and John Crimmins. You can go ahead and sign up with the second QR code listed here. The first one is actually a homepage to our whole series. So you can see what other topics we'll cover. Go ahead and bookmark it if you want to see what, if you want to come back, and I'll be populating it as time goes on. There's still a few slots I still need to fill in there. But that is it for today. So if there's anything else, let me see. Lars, thank you for dropping your email in there. We will be getting in touch with you. That's all we have for today. And I just want to thank our guest speakers and also our audience for taking the time to join us. So we'll be back. We'll be back next month. Thanks, everybody.
Thank you.
Bye.
Bye.
Bye.